Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. My name is Charlene O'Hanlon, and I'm the moderator for today's event, and I welcome you. As always, we have a great webinar on tap with some really great information for you, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you can access the webinar on demand later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for $100 Amazon gift cards. So please stick around. Hopefully you will be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is the importance of visibility and security of critical applications in cloud environments. Our speaker today is Scott Shin, who is CTO of Automacorp, Inc. Scott, thank you so much for joining me today. Really appreciate it.
Thank you very much for having me here.
All right. Well, I know you have a great presentation on tap, so I'm going to put myself on mute and let you get right to it, but please just let me know when you need me to advance your slides.
Great. Good morning, good evening, and good afternoon, everybody. Again, my name is Scott Shin. I'm the Chief Technology Officer at Automacorp, and we are a cloud workload security platform company. Starting out today, we're going to go over how the cloud and specifically container-based environments have changed the security landscape from what we're used to in enterprise security. On slide 2 now, the main thing that we can look at in the space of enterprise DevOps is that containers themselves have, in essence, increased the speed at which applications are deployed so quickly that it outraces a lot of our traditional internal security controls in forms of change management, in terms of auditing, and a lot of the tool chains themselves that we use in that space are very different. It's a very unique challenge. It's a very great opportunity that it creates for the rapid development and deployment of applications, but it also has created entirely new problems in that space. On slide 3. So some of the great benefits / concerns of this space is that the DevOps agility, speed and process by which we develop applications in that space can be, frankly, minutes and seconds. From the time someone develops a new application to the time that application is changed to the time that the application is deployed in a production environment, it can be, and frequently for us is, seconds, right? So we will deploy an application into our OpenShift environment, and it will probably, from the time it was written to the time that it's being used by deployed into our pods, it might be 90 seconds. And that's a pretty unique challenge on its own, because a lot of the security controls that we have traditionally used aren't really suitable for that type of problem. Secondly, those problems are magnified because these environments allow us to dynamically scale the applications up and down based on the amount of people that are using it. So I may have 10 running now, 110 minutes from now, and back to 10 after that. And during that time, we're exposed to, still exposed to the same security threats you would in any other environment. And those, the artifacts and elements that we use to identify attacks in those environments may be spread across lots of systems, and again, it creates a very unique situation for a unique problem to that stack. The last thing is that the delegation of where somebody actually owns the security duties in those spaces are muddled very much. So we say all the time that now your software developers are your infrastructure management people, whereas before you would go through a traditional software development lifecycle, hand it off to the engineering team who would then deploy it. And along the way, you have all sorts of different processes that can identify security issues before they go into production. So let's move on to slide 4 and talk about how we deal with that in a DevSecOps model, and really where this kind of breaks down. So you might hear the term, Gartner will use this, workload. So just kind of what a workload is to set the level, set this. A workload is anything, really. So it could be a dedicated bare metal machine, it could be a virtual machine, it could be a VPS, it could be a container, it could be a SaaS, right, like a CDN. So when we talk about workloads, it's kind of a generic way of saying these are all the things that we use in cloud-based environments. The pyramid here is Gartner's cloud workload protection security controls hierarchy. If you want a really big mouthful of acronyms to show in there. But really what we're talking about is it's a traditional security in-depth design, kind of working from the ground up. So from the bottom, meaning these are the fundamental foundational elements that we have to implement to secure workloads in this environment, all the way up to the top, which tends to be less and less important. And that's because a lot of what we're doing in a DevSecOps lifecycle is we have to build the security in from the ground up, because these things, are deployed very quickly, they're torn down very quickly, and to really try to leverage a lot of more traditional perimeter-based security models don't really work. So when we talk about the components of the pyramid here, all of these security elements are built into the workload, right? The workload, the pod, the infrastructure it's running on. We want to try to combine that across the board, because again, some of these issues we have in those environments are unique to workloads, right? So whether you're using dynamic scaling in Amazon EC2, or you're using Kubernetes, or you're using OpenShift with pods, traditionally what we're dealing with here are environments that we can't surround with classic edge-based security models, right? These things are just distributed. We have an attack vector, which can come in the form of not top-down, what we call north-south, but east-west, where we're looking at containers attacking containers that are, maybe being on another piece of shared infrastructure. So we have to kind of bake all of these components into the stack. That's your job. So the bottom part of this is the cloud owner's job, and Gartner wanted to point out in their presentation on this that the cloud provider themselves, their job is really only up to the hypervisor, right? The hardware, the physical security around it. But after that, it's your responsibility. And depending on what you're using out there, you may or may not be able to do all of these things. It's very unique depending on the technology stack you have in place. So let's move into slide 5 and talk about the security pitfalls in a hybrid environment. I mentioned the one already in the neighborhood of what we call an east-west attack. But when we get into the larger ecosystem of a cloud security environment, they tend to be mixed, right? There's a lot of there certainly are people out there in businesses that are dedicated 100% on one cloud platform or one technology stack, but in practice you have a lot of other things that tie into this, right? So we've got third-party APIs. Think of there's a platform in Amazon called Lambda, which is a serverless environment. There are integrations with third-party services like ServiceNow or Zendesk. You've got things like GitHub and GitLab. All of these things are other vectors into this environment, because these do move at such a speed that you kind of have to leverage a lot of these different APIs and other components into the environment. Secondly, the cloud environment itself, the environment that all this runs on, so whether we're talking like Amazon or Azure or Google, this isn't unique to any of their environments, but the actual cloud stack that is supporting your cloud application is a vector of attack, right? So there's a way around all of these things through, for example, the single sign-on part of these systems here called IAM. that would allow an attacker to access the environment that is controlling your environment. Last one is the ability to actually monitor the data across all of these components is unique, right? Because if we're dealing with sensitive data, PII, PHI, PAN, that's personally identifiable information, personal health information, or personal account numbers, in the case of financial data. It may be spread across a lot of different components. So just having part of the security stack focused on, say, for example, code review and code testing in the continuous integration system doesn't really give you much coverage when it comes to the fact that the data itself is spread across shared storage and multiple volumes and that sort of thing on the actual deployment side. So let's move on to slide 6 and talk about some of the critical application migration challenges themselves of when we're talking about a DevSecOps, and we'll talk about DevSecOps as it applies to this here in a second. But one of the ways that we deal with the speed problem or advantage, so just I guess it's another way to put it, is building the security itself into the development and the operations process, right? And that can mean a lot of different things depending on what you use. We are very much a GitLab, GitHub environment, and so when we're building applications in that space, we build the testing into our what we call pipelines. If you're not familiar with the concept, it's basically a way of automating a lot of the deployment steps, testing, bundling, deploying into the application before it's actually pushed into the cloud environment itself. Moving applications that are not built that way is in and of itself a fairly major task, right? You have to identify where all the data points come from and where you can actually build these controls around it. The second thing is that the various regulatory frameworks that handle this, PCI DSS is the Processing Card Industry's digital security standard. HIPAA, that's the healthcare standard. GDPR is the EU's data security standard, or data privacy security standard. Some of these may have conflicting requirements. So, whereas that alone can introduce some complexity to the way that this is done. As an example, PCI DSS requires a fairly stringent level of auditing on who uses data and how it's accessed. GDPR can be in conflict with that and require the that allows the owner or the user of that data, the human being that data is associated with, the ability to remove your ability to audit that, right? That doesn't happen a lot, but I have seen it happen a couple times. And in the cloud, it doesn't actually make this any easier because, again, the data itself may end up, one, being spread across a lot of different components, and two, we have a concept we call persistence, where the data itself might not actually be destroyed when you think it is, right? One that I think rings true for everybody who does this is that, every day the security threat gets bigger, and every day the number of people who can handle that doesn't really change that much. I mean, we grow a little bit, but by no means do the humans scale to the level of threat as it stands. So typically, I would say I've yet to meet anybody who said they had a fully staffed security team. I'm sure they exist, they're out there, but security people are very much in demand. And this skill set itself is not something where you're going to show up with 10 or 20 years of experience. The rate of change in here requires a pretty dedicated team member to stay on top of it. Last one I throw in here as a threat. It's a unique threat again to this environment because these services are basically charged by your usage, your consumption. And some of the attacks that have come in this space would be in the case of denial of service attack or something like that, which could drive up a company's, in essence, their cloud services bill. But equally, one of the challenges that could happen in these environments is by virtue of the fact that you're adding security controls to it, increases the amount of resources you need to use. And potentially, I've had this conversation with some accounting folks, that to the point where it actually costs more to, and I know this sounds terrible, it costs more to secure the environment than if they didn't secure the environment and paid the fees for, for example, non-compliance of PCI DSS. So that is a unique challenge in a consumption-based model, that the security stack itself could, the security controls you're implementing in your DevSecOps program could increase the cost to the point where it might be a threat on its own because of that. So let's move on to slide number 7 and talk about what are the requirements in a distributed environment, right? What is it that we ideally want to have across the board? So the first off is that we want to be able to have this be comprehensive, right? All the elements of the security pyramid, whether we're talking about hardening or memory protection or things like file integrity monitoring or deception. One, we want to be able to implement all of our security controls across the stack. This is the ideal, right? 2, we want to make this work cross-platform. So again, as you're moving across different types of technology environments, certain security controls may not be available. If you are operating in an environment where you need to have really strong memory protection and guaranteed memory protection for your applications, and you move into an environment where you don't have that level of access to the hardware, well, you can't really implement the control. And if it was critical to your design, say, for example, moving into a hosted Kubernetes environment where you're just a user of it, well, you can't really implement that, or you might not have access to all the data that you need. And lastly, I didn't used to even include this in this deck, but the costs really do matter. I had a federal government intelligence agency tell me that the reason why they couldn't actually secure a particular component of their environment was that the costs of installing the security, their existing security vendor in there, drove it up from 6 cents an hour to 16 cents an hour. Well, that doesn't sound so bad until you realize they had, so many systems that this blew through their entire budget for the year by May. So that is a concern, right? We can't just throw, a 2 gigabyte agent into a workload and expect it to scale economically in the environment. You just literally can't afford to do it. So let's go on to slide number 8 and talk about a little bit more about AtomiCorp and some of the projects that we're involved with and how we're using them to solve a lot of these problems. So again, my name is Scott Shen, and I am the CTO for AtomiCorp. I am also the community leader for the open source project called OSSEC. OSSEC has been around since about 2005. I am the 4th community manager to take over. I took over in about 2015. And OSSEC originally started as a host-based intrusion detection system, largely targeting desktops and classic enterprise usage. It certainly has grown and has had a great success in the open source security community on a lot of platforms, and you can see this down at the bottom. We support everything from certainly modern operating systems, all the way to legacy platforms like Solaris and even much older. I mean, this is one of those. This is kind of like the pearl of security. OSSEC is all over the place. And what does it do? It's a log-based intrusion detection system. It's a file integrity monitoring system. It has the capability of performing active response, and it is kind of duct tape. I mean, it allows us to take data from largely any other platform, whether we can put an agent on it or ingest data from an agentlessly and actually aggregate it all together and give a holistic picture of what's going on in the environment. It's certainly popular, as I mentioned. It's out there in largely every vertical. It's on every continent, including Antarctica, and it is in space. So we do know that it's used by several different actual space programs around the world. We have a lot of different contributors in the platform, both commercial and just community contributions from other security researchers. And we're up on GitLab. So if you're interested in checking out the OSSEC project, you can find us up on, GitHub. You can find us on GitHub. So let's move on to the next slide. And we're going to talk about how we, Atomic Corp, have augmented OSSEC to build an enterprise OSSEC. So OSSEC, as I mentioned, is an open source community program, like I said, with lots of users and lots of usage, but it's largely a text-based adventure, right? It is it is an analytics platform, it is an intrusion detection platform, but it isn't a pretty user interface, user experience. Atomic Enterprise OSSEC, we have taken the OSSEC project and other open source security projects and built a web-based management platform around it. One of the key weaknesses of OSSEC is it's very much built around that engineer persona, right? The engineer use case. And what we get into in cloud environments is as an engineer, your job is to solve problems and identify, risks and things like that and correct them. And that OSSEC works great for you. But then you're also working with people who are analysts who are looking more for the ability to work with lots and lots of data, and certainly cloud environments generate a lot of that. And then, of course, the management folks who need to make some kind of decision based off of what you're telling them. And that's a lot of what we've done in Atomic Enterprise OSSEC is we built a web-based management platform around it with those three personas in mind. And because of that, we can do things like generate advanced reporting. We can tie in directly to APIs in the IBM Cloud or Azure or AWS. We have also built in a crowdsourced threat detection intelligence service. Originally, we called it Super OSSEC, but as I mentioned before, we've gotten into a lot more than OSSEC. So OSSEC was sort of our core, but we also work with a lot of other open source security projects, either as direct contributors or like in the case of OSSEC, where we run the project, to include Mod Security, GR Security, OpenVAS /GVM, ClamAV, OpenSCAP, and many others. And a lot of what we've done in Atomic Enterprise OSSEC was try to get all those things working together, because as I mentioned earlier, sometimes you'll have parts of the threat, part of what you're trying to identify. Part of the story is going to come from one component, another part's going to come from another component. You might get the IP addresses from a CDN layer, you might get the file names from the FIM, you might get the users from a service like Audit. So you do need to build all of these together and kind of give a SIM-like user experience that fits in a cloud workload economic model, right? Like we don't want to dump a monster cluster in here to instrument the environment and drive the costs up. We want to try to fit this into as small of a space as we can. And the output of all this is the ability to drive workflow. So the workflow can be anything from blocking attacks in real time to reporting over something like Slack or Teams, or even generating tickets in platforms like ServiceNow or Zendesk or Jira. Obviously, it's a commercial platform, and we do fully support it. So that's also been a pretty big element of what we do, since we find a lot of folks are always, they're always looking for some level of expertise to augment the platform that they're using, which we do all the time. So let's move on to what our deployments look like on slide 10. This is an example used by a customer currently with about 6,000 workloads tied into our AEO, what we call Atomic Enterprise OSSEC, our AEO environment. This is probably one of the more complicated implementations. It's designed for high availability and distributed computing, and then also dynamic scaling. So our design is everything moves from the left to the right, whether a device has an agent or it's operating agentless. The data is communicated into basically a dynamic scaling layer. And this could be an Amazon EC2 type model or a Kubernetes pod. There's functionally no difference between either one. They are really just largely a clone-based service. And then we have a secondary or a primary layer who's designed to orchestrate it. And in the case of Kubernetes and OpenShift, that's an operator, right? So we use operators in OpenShift, in essence, to be we call it the orchestrator, but before we knew the term operator, but in essence, its job is to gracefully keep all of those things synced together and working in congruence with one another to aggregate the data. As I said, this is a pretty big deployment. A lot of times, this can be done in a single container or a single virtual machine. So, if you have many thousands, this is a many thousands design. If you have hundreds, it's pretty light. It's a single container, and I frankly have even run them to manage, on my desktop and things like that. So it's not a particularly massive footprint. Now, what do we bring to the table in addition to what I call operational or performance-based security? Which is performance-based security is the concept where we're mainly focused on responding to attacks and using automation to block them in real time, which is great. Me as a security guy, that's what I want to do. But in the security space, we also have to deal with a different model, which is a compliance-based model. Let's move on to slide number 11, where the threat in this particular environment was in the environment is regulatory. I don't mean that in a bad way. There are really good points to having a regulatory framework around whatever it is you're doing. But the concept of a threat there could mean fines. So in the energy sector, a group in the United States called the NERC regulates that on behalf of another group called FERC, and they can hand out some pretty significant fines for an environment being out of compliance in the millions or hundreds of millions of dollars. In nuclear space, they can shut down your reactor. In the healthcare space, you're looking at, again, fines and potentially more severe repercussions. And in the finance sector, they charge fees, right? So one of the elements that we responded to in our product was the ability to generate the artifacts to respond to that. And typically in a regulator environment, you have a set of security controls and you have to prove that they work somehow. We did this through a project called OpenSCAP, and this is a OpenSCAP report built into our product. So if our enterprise OSSEC is installed on the endpoint, it is capable of auditing the system multiple times per day, this being an output of that auditing program for whatever standard you're setting it to. One of the other advantages of leveraging other open source platforms for this, especially OpenSCAP, is that the regulatory frameworks themselves sometimes will require you to use a tool that's also been authorized. And we leveraged SCAP, or OpenSCAP specifically, because it is an authorized framework. We have a lot of customers in dealing with PCI DSS and a lot dealing with regulatory frameworks like by NIST, which would be in the federal government side here in the United States. And this does resonate pretty well with them. Let's move on to slide number 12 and talk about how our crowdsourced threat intelligence systems works. So early on, when we started putting together our platform, we recognized that just being able to instrument your own system doesn't really help protect you against larger meta attacks, right? So a meta attack would be in the form of say, for example, botnets or a term we'll use for intelligence agencies called APTs, advanced persistent threats. And what we saw initially, because we had deep instrumentation into web servers, would be certain types of attacks where the source rotates their attacking IP address, right? So, they would have one single login failure from one single IP, and then it would be a completely different IP in a completely different part of the world as another login failure. And if you're on the receiving end of that, just like being on the receiving end of a distributed denial of service attack, there's not really anything you can do about it, right? Because you really don't know anything about the folks coming in. So what we did is we built in a component to allow everyone to share their threat data anonymously into our system. We don't have a fancy name for it. We just call it TI, as in threat intelligence. But it is a Bayesian deep learning system where the attack data is shared from. It's an opt-in system, by the way, where the attack data is shared from your AEO node into our TI, and then it can be shared back out to everyone else in the that is participating in this environment, again in real time. So from the time when we detect an attack on one node to the time we can share to the other node, we say real time, but it's honestly it takes about 200 milliseconds. So we do as best as we can on that side there. But in practice, this has turned out to be something in the neighborhood of around 200 million lookups per day. We've got fairly deep capability across this because we are instrumenting every application. We're not just looking at something like port scans or something like that. We're looking at the data coming in from web application firewalls and DNS and whatnot. So where this can really make a big difference is when you're dealing with container-based and even serverless applications. You don't have that classic model where you can do things like firewall rules, right? You're limited in the level of access you can run in that environment. And even if you're doing that with a CDN up above it, you may not have the ability to inject a lot of applications or a lot of different blocks into that very quickly. So we're able to implement this at the application layer, so in a web server itself or in another application. So I have a couple questions coming in right now. So one of the questions I have is what kind of problems can the container side of this actually solve? So a big one, of course, is the ability to rapidly push a fix, right? And I mean really rapidly in a couple of minutes. So in a DevOps lifecycle, you can deploy these, in about 90 seconds because we do this all the time. That's a very strong advantage in that case. If we're talking about building that into an application, like something like this, again, it's adding it to the application as opposed to adding it to the infrastructure. It may be a lot faster to be able to do that. Let's move on to the next slide, slide 13. I know I'm sure I don't have a lot of time left here, so I want to get through. I've only got 2 slides left to go, so we'll go to the next one. Let's talk about how we are working with OpenShift. So right now we are in the Red Hat marketplace. There's the Red Hat IBM marketplace. You can find our platform there now. It's available. It runs on an operator. It is the server component of what I showed in the application before. This isn't the endpoint piece. It's the server infrastructure for managing. It's the brain, so to speak. It allows us to, using this in OpenShift, dynamically scale the environment. It's a lot less. There's not a lot of pain involved in scaling pods up and down. And if you're not familiar with Red Hat OpenShift, please go check it out because it takes a lot of the pain out of building applications quickly, especially if you're coming at it purely from a developer's standpoint, as opposed to being able to understand how these things go together. A lot of what we've done is being able to manage the security in the stack from the console. So while you still can make your changes in the containers if you're running our agents down in the endpoint, there is through the console the ability to effectively implement changes there as well. I want to hurry through my last slide here, so let's go to slide 14. And here we are, right here in the Red Hat Marketplace, where you can find us, because I would want to go to a couple questions and only got another couple minutes here. But you can find us on the Red Hat Marketplace. This is tied directly also to the IBM Marketplace. I'm sure the good folks at Red Hat can tell you more about how this works together. This is an operator-based model, so the advantage of the operator is its job is to maintain the actual application for you, as well as everything from updates to keeping everything nice and healthy. All right, so let's wrap it up there, and I'll go to questions from anybody out.
Yeah, so we have gotten some questions in so far. There is time for questions, so if you guys have a question, go ahead and send it on in. Let's see. Okay, here's a question for you. It might have actually been attached to something you were showing earlier, but the question is it just a defender, or can it show flaws in your system?
It can show flaws in the system. So when it's in place, the agent is capable of doing vulnerability scanning as well. So that's in the workload as it's running. Whether that is, there's two different types of vulnerabilities we identify. One are classic, patch missing type things. We scan for that every 6 hours. The scan time takes between 5 and 20 seconds, and it imparts no load on the actual workload itself. The second thing we do is we look at the way that the workload, vulnerabilities are related to the way it's running, like a setting, like a crypto setting or something in, authentication or something like that.
All right, great. Let's see, next question. How do you approach compliance using AEO across an organization's hybrid infrastructure?
So we have two different implementations for compliance auditing. One we use is called SCAP, that's the Secure Content Automation Protocol. It is outstanding on Red Hat and CentOS, but the content for it is somewhat limited. Like I said, it's focused more on those platforms. We also use CIS. CIS has content for the actual cloud platform itself, so like Azure, they have content for that. So where we can actually scan for particular things that are unique to Azure or Google or what have you. We did everything in this to be completely agnostic to the cloud itself. And so as long as it's something, where somebody made content for it, again, an issue of trying to come up with your own rules is you do have to get, sometimes with the regulated frameworks, you have to get them certified. So we use first already approved tools or methods like CIS is or something like that. The magic pixie dust that we put on top of that is the fact that we're kind of tying it, we're making a nice abstraction layer, kind of the way like Kubernetes does around containers. We're like Kubernetes around clouds, right? Like not so much orchestrating them, but getting inside of them, exploring different security threats and vectors in those spaces. It's a much longer conversation than I have time for. I would love to talk more about this at a different time.
Okay. All right. Next question. Do you have pre-built integrations for infrastructure provisioning and management tools like Terraform or Ansible? And what about SDKs?
We absolutely have them for Ansible and some tools like Packer. Haven't done Terraform yet. We have a great API for sending things to other things, right? So it's all REST and things like that. In that case, there's no difference from us talking to, say, VirusTotal as it is for us to talk to Cloudflare as it is to talk to Jira. It's basically a REST call. From our side, and this is even in the open source community, we have great contributions on that front. a really, really nice pre-built group of tools over there already for, you know, Slack and PagerDuty and FirewallD and Windows firewalls and all kinds of stuff like that. Of course, the API is the source code. You have that. The SDKs we have are covered on docs.atomicorp.com. So for the most part, again, we try to keep everything resty, so you can get away with a lot with just curl.
Nice.
Great question.
All right, great. Next question. Let's see. Is it possible to deploy the system on a hybrid environment and still get centralization done with only a few nodes?
Yeah, we'll have, you know, we've certainly had environments where the AEO piece was on-prem in their internal network, and then they're just talking over a TCP port. There really isn't. It's agnostic to the platform that we're talking to. A lot of times we'll have things that are not cloud that are also in scope, like the desktops used to manage it. So we will have agents on the desktop in like a PCI environment. And then we'll have stuff spread across all different, you know, Azure and Google and all that stuff at the same time, talking back to maybe a dedicated box in their own private data center. So there's really no issue in transporting that across them. Although I will tell you that one of the other things to bear in mind with most of your cloud providers is they do look at egress traffic, and they do charge fees for. They don't charge to put data in, but sometimes they'll charge data to get data out. It's something to be aware of when you're doing it. It's not a lot that goes through it, but you know, it really depends on what you're doing. If you're doing 600 gigabytes of, you know, event traffic a day, well, yeah, that's, you know, that might be a problem. You may want to keep it in the cloud environment, and you can stack these in a kind of a hierarchical design where you have like local servers just that cloud environment. I hope that answers your question.
Excellent. Okay, plenty of time for questions, guys. We have lots of them here, but there's plenty of time for more questions. So go ahead and use your GoToWebinar control panel and submit it if you have something. Don't be shy. Next question, why do people choose your container solution over other commercial solutions?
You know, I think one of the big ones, of course, is that we're open source, right? So, and we've been around a long time. So a lot of times what we found were people already knew OSSEC or mod security or what have you. They already knew these tools, and they wanted to, you know, they were happy with them. They wanted to move in with them. I remember when we did the first OSSEC con, I mean, the people attending were Netflix and Apple and, you know, all this stuff. And it's like, well, where did you find out about OSSEC? I'm like, well, I started using it, you know, in school. So there's definitely that process of comfort level. Definitely with cloud engineers and architects, they love to get inside of the code and crawl around and understand just what's going on in that space. The other side of it is they didn't, you know, this is probably not unique to anybody, but you know, you've got cloud architects that are doing all this very hardcore design work, but then they have to hand it off to other teams who aren't as familiar, and so they need that, you know, hug, so to speak. They need that web-based user interface. I mean, the architect was used to, you know, logging into the box and tweaking the, you know, bunch of config files by hand, but now I've got to hand it off to a team that runs 24/7, and I got to minimize the variables that they're gonna, you know, that they may have to work with every day because they've got to scale, right? So a lot of it has to come is that sort of the hug you get when you've got a web-based UI and you've got a team with, you know, for support. As far as the actionable security, I mean, we came at it. Our design was always make it self, you know, defending up front, and then we added in all the compliance piece. So we've always had a pretty hardcore brand on actually building systems that can, you know, respond to attacks by themselves, and we're comfortable with it. I recognize a lot of people aren't letting a machine protect itself or reconfigure firewall rules automatically, but that was always our strength in that space. And we have especially in the WAF space, the web app firewall space, we've always had a really, really strong brand in there, and a lot of people trusted us because of it.
Excellent. Okay. Next question. What is your typical minimum deployment size?
We've done it down to one. So we have the runtime of the back end of this. Most of the components, for those of you that are engineers on the call, it's C. So the runtimes are in K, not megabyte or gigabyte even. The second thing is we designed the entire runtime to fit in a T2 medium, a 2 gigabyte virtual machine that was already doing something else. So you can fit an entire, we call it AWP just by itself, not AEO, atomic workload protection, on a single system that is doing something else. You know, that it's a web server, a mail server, a DNS server, whatever. You can put the whole stack on it, including the GUI, and it all fit into one single machine.
All right, so next question, what are the plans for the OSSEC conference, OSSEC conference, and how can people participate?
So our conference will be the December 1st, I believe, December 1st, 2nd, and 3rd at the moment. It's going to be a virtual conference. Days 1 and 2, we might do 4 days now, I think about it. But days 1 and 2 will be presentations from security researchers, from, you know, certainly me in my open source capacity, as well as my Atomic Corp capacity. We're going to be covering some of the new tools that we've got coming out around integrations with tools like Elasticsearch and active response systems and zero trust networking. There's a lot of really great content. We had some great researchers joining us this year from all over the world, which I'm excited about. And then the rest of the conference, I think we're doing 2 days of workshops. We'll be doing that in a virtual environment that is web-based. And we're going to do hands-on, basically a lot of hands-on sessions with fully interactive platforms. So SIM integration and zero trust networking. And we have this great presentation from another researcher on automating compliance, which I thought was really exciting. So certainly you can check out our announcements, I think, up on the Atomic Corp page, where we're pasting the syllabus, which is changing as more and more researchers join in. So it's entirely possible we may go longer than the 2 or 3 or 4 days, but we're trying to be sensitive to everybody's time. And if you can tell that I sound excited by it, I am, because we had a lot of really cool stuff come up since our last conference a few months ago.
Excellent, excellent. So let's take a few more questions here before we close things down. And I know you mentioned that you've done deployments as low as 1, but the question here is there a size of deployment below which this is overkill or just not the most cost effective?
I think if you had a single container, that's probably too much. I don't know. I mean, we have people that do single containers, so it's hard to say how big is too big. I mean, we definitely have a really strong user base in small and medium businesses, and a lot of times they'll have single systems or maybe 2 systems, and it's fine. So no, I don't really know that. I mean, I can't go. How much smaller can I go than 1?
That's a good question. All right, great. Okay, here's a good question for you. What kind of support comes with this?
So we're US based. We use tools like Zendesk. Our support is certainly email, and we do Zooms, but we will do hands-on. So built into the product is the ability to, 1, generate tickets with us, 2, give us access over SSH or even over VPN connections. So a lot of times, if we certainly do things way past, I think, what other companies our size would normally do into the integration space. But we'll get on the systems with you. We do online training through the same web-based system that we'll be showing at the OSSEC where we're able to give students their own environments to play around with and break. So it's pretty extensive. Frequently our support team, is more than happy to do the install for you.
Okay. All right, great. I think we have time for 1 or 2 more questions before we close it out. Next question, is there any anti-flooding feature to prevent large bursts of intrusion events?
To some extent, there's a fair amount inside of the IDS engine itself that it doesn't have to maintain every single file or every single event. It can do aggregation on them. But really, it depends on the nature of the flood. If we're talking DDoS, no, of course not. The only way to defend that is with a CDN or something. But high volume of events going into the IDS engine. The IDS engine itself doesn't need to save every single event, right? It's going to look at them and aggregate them, and do counts and stuff like that. So it's pretty durable on that front. I can say safely that a workload of has about 32 gigs of RAM, handling 600 gigabytes of traffic of event traffic a day, right? But when it writes it to disk, it's more like 6 gigs, right? So it really depends on the nature of the events, but it can scale. And in those spaces where you get to something where the traffic is even higher than that, well, it supports clustering, right? So you can throw it into a pod and then let the pod scale it up and down for it.
All right, great. Okay, let's go ahead and make this our last question here. What are the limitations on the free trial, if any?
There are no limitations at all. So run it on one system, 100 systems, 1,000,000 systems. We don't do things volume based anyway. So there's nothing feature restricted about a free trial.
Okay. All right, great. Well, with that, we'll go ahead and close out the question and answer period. I think we got to actually all the questions that came in, but if for some reason we didn't and I missed it, I apologize. But please note that the folks at Atomic Corp and Red Hat Marketplace will be getting a copy of all the questions that came in, and I'm sure they'll be more than happy to follow up with you offline to get your question answered. Also, a quick reminder to everybody that today's event has been recorded. So if you missed any or all of the event, you will have the opportunity to access it again later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website. So you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, at the top of the hour, I did mention that we would be doing a drawing for $100 gift cards. So without any further ado, let's go ahead and do that drawing. Our first winner today is Diego G. Congratulations, Diego. Second winner today is Jim M. Congratulations, Jim. Third winner today is Lindsay S. Congratulations, Lindsay. And our final winner today is Todd C. Congratulations, Todd. We'll be following up with you for offline by email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam filter. Scott, what a great presentation. Thank you so much for your time, your expertise, judging from the number of questions we got from the audience. Very well received, lots of great information. So appreciate it. Appreciate your time. Thanks for joining me today. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.